Rohini College of Engineering and Technology. I am Vetrivel, Associate Professor, Department of Physics, Rohini College of Engineering and Technology. In this video, we are going to discuss about superconductors, which is in the material science subject PH 8251. Course outcome. Upon completion of this course, the students will be able to explain the properties of superconductors. Now let us see what are superconductors or what is superconductivity. Actually, superconductivity is one of the most exciting phenomena in physics. It was discovered by Dutch physicist H.K. Once in the year 1905. The superconductivity appears to be the biggest revolution that occurred recently in physical and material science since the invention of transistor. Now let us see how the superconductors were invented by the scientist. Before the discovery of superconductivity, it was thought that the electrical resistivity of a material becomes zero only at absolute zero temperature. But later it was found that in some materials the electrical resistance suddenly falls to zero when they are sufficiently cooled below a certain low temperature known as critical temperature, and it is represented by Tc. So this phenomena was first observed in mercury by H.K. Once. Mercury is actually a normal conducting material, but when the temperature of mercury gradually decreased, when the temperature reached 4.2 Kelvin, suddenly the mercury becomes superconductor. That means when the temperature reached 4.2 Kelvin, the electrical resistance of pure mercury becomes zero, so that the electrical conductivity of mercury is infinite. This strange phenomenon was observed by H.K. Once, and by doing various experiments on various materials, as a result, hundreds of superconductors were invented by the scientists. Now, let us see what are superconductors. When a material or an alloy is cooled below a certain temperature, it suddenly loses all its electrical resistance. The zero resistance phenomenon is known as superconductivity. The material that exhibit these super properties are called superconducting materials. The current which flows during superconductivity is known as supercurrent. Simply, there will be no loss of energy in any form by the superconductors because of its zero electrical resistance. Now we have to see the various properties of superconductors. The first property, electrical resistance. The superconductors have zero electrical resistance. We know if there is no resistance, the current conductivity will be enormous. That is a important characteristic property of this superconductors. The second property, effect of magnetic field. The superconducting property can be destroyed by the application of strong magnetic field. When the superconductor is placed in a strong magnetic field, the superconductor will lose its superconducting property immediately. Now let us see the figure. The temperature is given along the x-axis and the magnetic field is given along the y-axis. So up to the critical temperature and also up to a particular magnetic field, the material is in the superconducting state. So now let us see what is this transition temperature. Transition temperature or critical temperature is nothing but the temperature at which the superconducting materials are changed into normal conductor. Otherwise, we can say the temperature at which the normal conducting material will be changed into the superconducting materials. That's why this temperature is called as a critical temperature. Now, let us see the magnetic field. That value is given along the y-axis. Up to a particular magnetic field value, that means up to a low magnetic field value, the material behaves as a superconducting material. But when the external magnetic field value exceeds this particular value, the superconducting material losing its superconducting behavior and immediately changed into the normal conducting material. That means their electrical conductivity will be varied. Either it will be increased or decreased, depends on the applied external magnetic field. So this magnetic field is called as the critical magnetic field. Already we saw the critical temperature. Now we have to see the critical magnetic field. So what is critical magnetic field? So the minimum magnetic field required to destroy the superconducting property is called the critical magnetic field, Hc. Otherwise we can say at the critical magnetic field value Hc or above this critical magnetic field value Hg, the superconducting material becomes normal conductor, or below this critical magnetic field value Hc, the normal conducting material becomes superconductor. So this magnetic field is called as the critical magnetic field, Hc. The third property, effect of heavy current. The superconducting property of any material can be destroyed by the application of strong electric field. So every material has a limit. When that limit exceeds, the property of every material will be changed. That is happened in the property of superconductor also. When we are using the superconducting material in some electrical circuits, suppose a heavy current is flowing through the circuit, at that time the superconducting material will lose its superconducting behavior and it becomes the normal conductor. That means its conducting capacity will be decreased. That is the reason. Now let us see the fourth property, persistent current. So what is meant by persistent current? Now we have to consider the superconducting material in the form of a ring, as shown in the figure. When a superconducting ring is placed in a magnetic field, the current is produced in the ring. This current persists in the ring without any decrease in its value. This current is called persistent current. That means when the normal conducting material is placed in the magnetic field, the current is induced due to electromagnetic induction. But after a particular time, the electrical conductivity will be decreased due to resistance of the material. But when the superconducting material is placed in the weak magnetic field, the current is produced due to electromagnetic induction, but even though the external magnetic field is removed, the current is persisted in the superconducting material. That means there will be no decrease in the value of the electrical conductivity of the superconducting material. Since the current is persisted in the superconducting material, it is called as persistent current. Now let us see the fifth property, Meissner effect. When a superconducting material is placed in a weak magnetic field and cooled below its transition temperature, the magnetic lines of forces are excluded from the material. This effect is called Meissner effect. Here we have to see two figures. In the first figure, let us consider the normal conducting material. In the figure, the blue circle is nothing but the normal conducting material, which is placed in the weak magnetic field. The magnetic field is represented by the various lines with the arrowhead as shown in the figure. Now when the normal conducting material is placed in the weak magnetic field, all the magnetic flux lines are penetrate through it. That is, B is not equal to 0 inside the normal conducting material. We can see the magnetic flux lines are penetrated through the normal conducting material as shown in the figure. Now let us move to the second figure. When the temperature is reduced below the critical temperature, now we can say the material, the normal conducting material is changed into the superconducting material. When the superconducting material is placed in the same magnetic field, all the magnetic flux lines are excluded or pushed away from the superconducting material as shown in the figure. Now we have to see no magnetic flux lines present inside the superconducting material. So this phenomenon is called as Meissner effect. So that we can say the superconductors are perfect diamagnetic materials because two diamagnetic materials will repel each other. Now let us see the final property of superconductors, that is nothing but the effect of pressure. The transition temperature of superconductor is increased by increasing the pressure. That means we have to consider cesium. Cesium is a normal conducting material, but on increasing the pressure on certain materials like cesium, it will be changed in the superconductor. So when very high pressure is applied on such materials like cesium, it is immediately converted into superconducting material. This is a very important property of superconductors. So from this video we have clearly discussed about the superconductors and the various properties of superconductors. Thank you.